Hi and welcome, my name is Joshua from TAG. This video is the second part of the video I did on the major spread in R, and what I intend to achieve in this video is to provide like an alternative route to some of the things we achieved in the previous video using other packages that are available in R. So don't forget the data we used in the last tutorial is the Chick WTS dataset, and so what I'm doing right now is to store this dataset in an object called DAT. So don't forget, in this dataset we have 71 observations of two variables, information for weight and information for feed. So let's have an idea of the numbers of the observations we have for the unique levels of feeds that we have for this dataset. So let's say table, and then we can say that $ feed. If we run this, so we have an understanding that we have just feed, 12 of them belonging to casein, 10 for husband, 12 for linseed, 11 for meat meal, 14 for soybean, and 12 for sunflower. So we can as well get like the proportion. So all I need to do right now is to copy everything I have on top and say this divided by 100. So if I run this, so we have an idea of what this proportion, like all over 100, looks like. But if we are to do this proportion with reference to the total number of rows we have for the entire observation, so what I'm going to do wouldn't be for me to just divide it by 100, but to divide it by the total number of rows we have for the entire data, which is number of rows like we've seen, which is 71. So I'm going to say number of row for that. So if I run this, and then we have these proportions that we have on the console. So to check if this is actually accurate, you can take the sum and then take everything we have, copy everything we have on line 5, paste it here, and if you run, for sure we're going to have an answer that is equals to 1. So one thing I am going to explain here, like I said at the beginning of the video, this is just to provide like an alternative to what we've done in the previous, using some other functions or packages that are available in R. So one of the functions I'm going to use right now is the tapply function. So with the tapply function, you know, we got the standard deviation and the variance in the previous video for feeds that are particular to casein. Now it is easy for us to do this for all the levels of feed at once. I wouldn't have to be doing something like variance, and then we have to say variance of that for that $, feed that is equal to, let's say, let's copy everything we have here, that is equal to casein. So in quote casein, and so that is equal to casein. So then I can just put comma, and then I am getting the information for the weight. If I run this, this is the value we have for the variance the other time. So let's take for instance now that I'm also going to do this not just for one level, I also want to do it for the next level, which is husband. So what I'm going to do is to paste what I've copied and then change this particular place from casein, turn it to husband. So I copy what I have in this place and then I paste it at this level. So if I check, that of husband is 1491.956. Let us assume that I'm doing this again not just for husband. Let's assume that I'm doing it for linseed. I copy everything I have and then I paste, and then I change the information that is there for husband, I turn it to linseed. So if I run this, I'm also going to have like a different value for the variance for that particular level of feed. So this is going to take a lot of time. So to do this, we have a function called tapply. So I'm going to say tapply from the apply family. So I'm going to say tapply from the base package, and I impute the data. So I'm saying that $ weight, and then specifically for the feed. So what exactly am I starting with? I just want to compute the variance. So if I run this, then I have at once the variance for each of the levels, just like what we could just see on the console. Now you see we stop at linseed. This exactly correlates with what we have in this place. So the same thing is applicable if you are taking like the average distance of each of these observations to the mean, which is the standard deviation. So the same thing is applicable. You change the var that we have in this place to SD, and so when you run this, you also have this particular information for the standard deviation for all the unique levels of the field. So the next thing we want to do now is to learn how to use some functions available in the dplyr package, the package for data manipulation, to achieve some of the things we calculated in the previous video. So to activate this particular package, we use the library function, library, and then dplyr for data manipulation. So let's start by using this pipe, the old pipe function, and I'm going to use this group by. I am grouping by the feed, and so what am I doing next? I want to use the summarize function, and the first thing I want to do is to have like the number of observations that we have for each level. So I'm going to call it tn, and then I'm just going to use this n in this way to like count all the number of observations we have for the levels. The next thing I'm going to do is to have like the mean, so I call it mn, and then I'm going to say I need the mean for the weight, so I say mean of weight, and then I usually do this for the mean na.rm. So whether there is missing value or not, I usually do this. So then comma, the next thing I'm going to do is to say let's get the variance, so I call it var, and that is just going to be the variance again of that numeric variable we have, which is the weight. So comma, I also need the standard deviation, I call it the SD, and that will be SD weight again, comma, and one thing I'm going to do here that I have not done in the previous video is to get the coefficient of variation. So I'm going to call this V, and that is the standard deviation of weight divided by the mean of weight. Let's multiply everything by 100. So this multiply by 100. So let's scroll down and run this entire line of code. So we are expecting to have like a table of this form. Let me scroll everything up. So you could see here for the feed casing, the total number of observations we have is 12, the mean is 324, the variance is 4152, the standard deviation is 64.4, and the coefficient of variation is 19.9. So let's move again to how we can compute like the kurtosis and the skewness. So there is a package called moment, so I'm going to load that package using the library function, and then I say moment. So very easy. In this case now I just want to index to a specific feed to make this a bit very easy for us. So I'm going to say that, and then square bracket that, again the same concept we used the other time, and then the first one we just want to try as an example for the skewness and kurtosis is the casing. So leave the condition for the row and then provide it for all the column. So if you run this, mind you, you're going to have information belonging to casing alone. So now we want to get the skewness. So using that particular moment package, so I'm going to copy everything I have in this place, and then I want this information for weight values belonging to casing. So if I run this, I could see the value of the skewness, and at the same time I can get the kurtosis. So I'm going to copy everything I have again in this place, and then go ahead with computation of the kurtosis, paste, and then I can easily run this. So I could see the value of the kurtosis. So there is one interesting package again coming from by the name Psych. So I'm going to load that package, and this package does something very interesting. It provides like a general overview, like a general statistics on the particular data that you provide as an argument. So I'm going to say library, and then I say Psych. If I load this, the next thing I'm going to do is to use this function from Psych called describe. So I'm going to say describe, and I'm not going to do it for all. I'm also still doing it for weight values belonging to the casing field. So if I copy this and then I impute it in this place, if I run, you could see it provides at a glance information about the number of observations we have for that particular field, the mean, weight, the standard deviation, the median, the trimmed, the MAD, the minimum, the maximum, the range, the skewness, the kurtosis, and the standard error. So these are some of the few things we can do as regard the measure of spread in R. So at this point, I want to say a big thank you for your time. Thank you for choosing to learn R with me. I hope to see you in the next video. Till then, do have a great day. Bye.